the definition of the torque is a vector, and the definition of the torque is that the vector torque is obtained by watching the position, the vector position of the particle cross F. This is the definition of the torque, and the magnitude of the torque of this cross product is the magnitude of R by the magnitude of F by the sine of theta. This is the magnitude. So we define a vector by his magnitude, and the direction. You know what is the direction? Is you apply the right hand rule, and you get the direction. So the point is like this. Why we need to define a torque? Let's say that you have an object. Let's say that you have a disk. And let's say that you apply a force like this one. This force will not produce rotation. Why? See like this. This is R, and this is the F. R cross F have a torque, and the magnitude of the torque is 0. Why? Because this is magnitude of R by magnitude of F by the sine of the angle that they form, that is sine of 0, but sine of 0 is 0. So the torque is 0. What it means that the torque is 0? It means that this force will make a translation of the body, but will not create rotation. So we need to create rotation. So we need to apply forces to the body that can create rotation. So this force is a valid force to create rotation. Why? Because this force has a component through the tangent that will create rotation. So the idea of torque is that when you are talking about objects that are rotating, the torque should be different than 0. If the torque is equal 0, it's meaning that the object is not rotating. So if the object is not rotating, we are not studying the rotation of the motion of rotation of the body. We are studying the translation of the body. So the torque is a basic vector, a basic tool to understand the rotation. So we have defined the torque like R cross F, and let's go to, we did this in class, but let's go to review this with these pictures. We see here that the torque, from example, from this force, the torque is through this axis, because this is the torque through some axis, because R are measured through some point. So you have to measure the torque through some point. So let's say that this is the axis that is going to rotate. The axis is going to your eyes here, is this point that is going to your eyes, and this is through this which you apply a force like this one, let's say. Is going to produce a force? It's going to produce a torque? Yes, because R is in this direction and F is in this direction. The angle is 90 degrees now, and the magnitude of the torque is maximum, because sine of 90 is 1. So this force will produce a torque, and will produce a torque that will make the object the object is this one, of course, it will make to rotate the object in this direction, counterclockwise. So we call the counterclockwise direction as a positive torque, and we call the negative clockwise, the clockwise direction as a negative torque. So it's a vector that's going through this axis, the axis that is this torque is going in this. If you apply this force, the torque is going to produce an acceleration in this direction, and means that the torque is going to your eyes in this case. Okay, so so we saw this in class, and we saw how the force and the distance is applied. If this is the point that you are calculating the torque, this force will produce a torque that will be the force by this distance, the perpendicular distance. So you extend the force, the line of the force, you extend the line of the force, and the torque will be the magnitude of the force by this distance, the perpendicular distance. This force, for example, will not create any torque because R and the force are parallel, so sine of 0 will be 0. And this force will create a torque, but it will be a negative torque because the force will have because the cross product of R by F will go clockwise, will go clockwise like the but in difference with this F1, the cross vector of F1 by R, it will be this distance R, the cross product of R cross F will be C. This is R. I put it. I continued the R. This R. I put it here. R cross F will generate a rotation that is counterclockwise, so it's a positive. While this point, the vector R is like this. So I put it R here, and I make the rotation of R cross F. R cross S will make a rotation that is clockwise. So this force is making a negative torque, while this force is making a positive torque. So to make it more clear, I have done some pictures. Let's go to see the picture that I have done, so maybe you can understand better what is done here. Let me see, let me go down. Okay, so we have said that the torque is R cross F. We have said that the magnitude of the torque is magnitude of R by magnitude of F. By magnitude of F, there is no cross product here. Magnitude of R by the sine of the angle. Okay, this is the magnitude of the torque, and the direction. A vector is completely defined if you tell me the magnitude of the vector and you tell me the direction. The direction, you know how is the root of the right hand side. So let's go to study these two situations. This is the point M. I apply this force F, and this is the vector R. So I want to do R cross F. R cross S, the magnitude. How can I visualize this vector? So R cross F is a vector. The direction will be very easy. The direction will be R is like this, and F is like this. So the direction will be R rotating to R cross F is rotate R through F. So if you rotate R through F, the direction is counterclockwise, so it's a positive direction. So the vector tau that I'm going to define is here going to your eyes. Tau is positive. So, okay, this is fine. Let's go to analyze the magnitude of the torque. The magnitude of the torque, there are two ways to analyze. The first way that I think that you can do it is like this. Construct an axis parallel to R. Construct an axis parallel to R and perpendicular to R. You see, this is R. I construct two axes, one parallel, one perpendicular. So this force, the angle that they form R with F is this angle theta. So I have that the magnitude of the torque is the magnitude of F by sine of alpha by the magnitude of R. So what is F sine of alpha? F sine of alpha is this quantity. This quantity F is F sine of alpha. So F sine of alpha is in some way, you can call F perpendicular, or F tangent if you want, F perpendicular by R. Because magnitude of F by sine of alpha is this distance by this distance. This is the magnitude of the tau. But there are another way to do it. This is the first way to do it, to visualize. The second way to visualize the cross product is like this, second way is construct two x's again, but now instead of construct two x's, one parallel to r and another perpendicular to r, construct one axis parallel to f and another one perpendicular to f. So what is magnitude of f by r by sine of alpha? Is magnitude of f by r sine of alpha. But r sine of alpha, look at this, r is this amount, r. R, I can put it here if you want. R is here. This is theta, r sine of theta. Sorry, I put alpha instead of theta, but it's theta, always is theta. So r cosine of theta will be projecting r over f. So what is r sine of theta? Is this quantity. This quantity, r sine of theta. So the tau, the torque, the magnitude of the torque can be visualized like F, the magnitude of the force, by the magnitude of the perpendicular distance, because this r perpendicular is r sine of alpha. So either you do the cross product, visualize the force and visualize this distance, or you do the cross product, visualize the force, that is tangent, perpendicular to r, the force that is perpendicular to r by r. So two ways of doing F perpendicular. Let's go to put here instead of F perpendicular to r by the magnitude of r. So the magnitude of the force perpendicular by r, this is the torque. And the other way is the magnitude of the F by the r perpendicular. And this is the picture that you can see clearly why this is have sense. So let's go to the part 3, to this. This is the definition of the torque, okay? This is the definition of the torque. This is the right-hand rule, R cross F. R cross S will, you see F go out of the paper, so it will go like this, out of the paper. What it means out of the paper, it will means like this, R, F. So I will rotate R is this vector, through F. So it will produce a rotation that is counterclockwise, so it will go up. So the torque is here. In this situation, the torque is going down. Why the torque is going down? Because R is like this, and the force, it's say, out of the page. So out of the page is something like this, out of the page. So R is this one, and if you rotate R through F, will generate a rotation that is clockwise. So clockwise means going down. Clockwise means going down, negative. Counterclockwise means going up. Okay, positive and negative. Okay, so this is the depth of the torque, and this is the problem that we did in class. And please review this problem and calculate the torque again. Okay, calculate the torque again for this problem. Okay, good luck.